Now we move to next section, which is Deterministic Survivorship Group. We start with LA tau. Observe this group from year to year until all have become a decrement. So for Deterministic Survivorship Group, we only focus for one group. Meanwhile, for Random Survivorship Group, we just take random people. So as the definition, Lx tau is the number surviving to each x from a group of La tau. And Lx with the cos j, number who will become a decrement due to cos j after attaining each x. So this is how we draw the timeline. So this is, we start with La tau, and here is Lx due to cos j, who still survive due to cos j. So Lx tau is the summation of all the Lx j from j equal to 1 until m causes. Next notation is n dx tau, number who will become decrement between each x and x plus n. And we can find n dx tau by using this formula, Lx tau minus Lx plus n tau. N dxj, number who will become decrement due to cos j between x and x plus n. And we can find n dx cos j by taking Lxj minus Lx plus nj. For the case when n is equal to 1, we write down the notation like this, dx tau, with known that n is equal to 1, so from x to x plus 1. Same to dxj, due to cos j from Lx to Lx plus 1. Next notation is nqx tau, which is proportion of Lx tau who will become decrement between each x and x plus n. This is the probability. So we divide n dx tau with Lx tau to get nqx tau. Next is nqxj, proportion of Lx tau who will become decrement due to cos j between each x and x plus n. So instead of using n dx tau, now we use n dxj, but still we divide with Lx tau. And for n equal to 1 case, the notation would be like this, and we take from x to x plus 1. Next section is associated single decrement table. Previous section we learned on multiple decrement table. So now we want to convert it in terms of single decrement table. So the first notation is qxj, which is the probability of decrement between each x and x plus 1 due to cos j is in competition with other causes. So we have more than one cause. Second one, qxj with prime, which is the probability of decrement between each x and x plus 1 due to j is the only possible cause, or we can call it as absolute rate of decrement. So we have only one cause, so single cause. So basically, Qx prime is greater than Qxj because we have only one cause. So we can also write down in terms of Px, where Qxj prime is equal to 1 minus Pxj prime. And to find the Qx prime j, we integrate the PDF. So the PDF is Tpx mu x plus t with prime. So mu x plus tj with prime is force of decrement at time t due to cos j when j is the only possible. So the standard assumption, the first is mu x plus t with prime is equal to mu x plus tj without the prime, the normal one. And finally, we get Tpx tau is equal to product of Tpxj with prime. Next section is the construction of associated single decrement table, where we transform MDT to SDT. MDT is the multiple decrement table and SDT is single decrement table. So there are some assumptions that we have to know. First is the constant force of decrement. Second is uniform distribution of decrement in multiple decrement model, or we call it as UDD-MD. And the third one is center rates in the multiple decrement model. So first assumption is constant force. Constant force for each decrement over each year of each. So this is the force of decrement. And finally, we get force of decrement cos j divided by force of decrement tau times Qx tau. And finally, we get Qxj prime is equal to 1 minus Qx tau, the power of Qxj divided by Qx tau. Second assumption, UDD-MD over each year of age. So UDD, where TQX tau is equal to T times QX tau. Then we differentiate, we get TPX tau mu x plus T with the cos j. And this is when the force of decrement is equal to TQXJ over TPX tau. Using UDD-MD, we get this one. And for the standard assumption, it's equal to mu x plus t j with prime. So Pxj prime is equal to E negative mu x plus t prime j. And finally, we get this one. Qxj prime is equal to 1 minus Qx tau, the power of Qxj divided by Qx tau. So the numerator is UDD and the denominator is using constant force. This is how we get the equation. The last assumption is center rates. The notation for center rate is mxj, center rate of decrement from cos j for multiple decrement model. So this is the standard definition. When we use UDD-MD, the center rate become qxj divide with 1 minus half qx tau, where mu x plus j is equal to mu x plus half j. So this is how we get this one. So mu xj with prime is center rate of decrement due to cos j for ST, for single decrement. So this is the standard definition. And finally we get this one. Since standard definition is equal to this one, so qxj is equal to this one. This is for UDD-ST, single decrement. Previous slide is UDD-MD for multiple decrement. Now we want to construct multiple decrement table using SDT. So we transform SDT to MDT. There are 4 assumptions that we have to know. First, constant force of decrement, CF, uniform distribution of decrement in multiple decrement model, UDD-MD, uniform distribution of decrement in single decrement model, or UDD-SD, used if any Pxj is equal to 0. And finally is center rates, which is Mxj. First and second assumption, this constant force and UDD-MD. So this is MD in terms of SDT. The third one is UDD-SD. So UDD, we use T times QX. And finally, we get QX cos 1 is equal to QX cos 1 prime times with 1 minus half QX2 prime, and as well as QX2. So we just change the cos inside the bracket. And for the last assumption, for center rate, this is the standard definition. And finally, we get this one. Qxj is equal to 1 minus half Qx tau divided by 1 minus half Qx prime j times Qx prime j. Now, let's look at the example. The first example, we are given force of decrement 1 and 2. So we have 2 cos here. And the first one is constant 0.01. And this is De Moivre's law, 1 over 100 minus x minus t. So this is the omega 100 minus x. So the omega minus t is the denominator. So x is equal to 20. So we have to find px prime 1 and px prime 2, and we have to find qx1 and qx2. So prime for the single, and without the prime is for the multiple. First, we use this definition where mu x plus t is equal to mu x plus t prime equal to 0.01. And then we find the px prime 1 by taking exponential with the constant, and we got 0.99. Since it is constant, so we just substitute inside. So to find qxj prime, we have to use this formula. Qx1 without the prime is equal to 1 minus px1. So we get this one. So we substitute from here. Then we want to find qx2. First we can find px2 from the information given. So p22 is omega minus x minus t over omega minus x for de Moivre's law. So we get 79 over 80. Then we can find q22 by taking 1 minus p20 for 2 is equal to 1 over 80. So now we can get qx tau. Qx tau is the summation of q20 cos 1 plus q20 plus 2. So we get 0.02245. And this is for the denominator for this one. Now we can find qx2 prime. So this is 1 minus qx tau, which is equal to px tau. So px tau is px1 times px2. So we take from previous one, e negative 0.01 times 79 over 80. So this is qxj 1 over 80. So qxj here is qx2, and this is qx tau. So we take from previous one. Then we substitute the values and we get 1 minus 0.9875. So from this we can get px2 prime is equal to 0.9875. And we can find qx1 and qx2. Actually, we already found in last slide. So this one is constant, where force of decrement is constant, and this one where the force of decrement using the de Moivre's law, the mu x plus t for number 2.